That could happen as well. I have all kinds of ideas. Yo, I don't have enough. Wait for the camera. All right. Let's go through these. Suppose I'm going through this homework. I want to make sure you're good. Suppose you have a 1 gram of a mixture that is using 1% of its mass, losing 1% of its mass each hour by evaporation. What is the decay factor of the mixture? So is it growth or decay?
Well, it says decay, so this would be decay.
Good. So remember, that's the equation we're going to use. So we have 1 gram. We have 1 gram that we're talking about. It says that it is losing 1% of its mass every hour. So B is going to be 1 minus 1%, A, which is this. So each hour that goes on is going to be worth 99%. It's going to be 99% of what it was the previous hour. So that's the equation you're going to use right there. Use the formula and your calculator to predict the time when there will be 0.1 grams left. Okay? Sound okay so far? So, if we want to know when we'll have 0.1 grams left, we're going to do this. 0.1 equals 1 times that. So I'm going to write that a little easier. Why can I get rid of the 1? Because 1 times a quantity is a quantity, right? All right. Anybody have any idea what mathematical property brings exponents down front? There's actually 2 of them. They both start with an L. Log. Log and natural log bring nothing. Log and natural log will bring the exponent down front. I like to use natural log for the most scientific reason in the world. ln. ln has 2 letters, log has 3. I just don't have the energy to write 3 letters, so I'm going with 2. So I'm going to go with natural log of both sides. Okay? The answer is the same regardless which one you use. This is going to allow the exponent to come down front. So I'm going to get ln of 0.1 is equal to x times ln of 0.99. Okay? How do I get ln 0.99 to move over? Divide. So I'm going to divide each side by ln 0.99. So x is going to be equal to ln of 0.1 divided by ln of 0.99. Plugging this into your calculator, it should deal with it nicely. And again, natural log brings the exponent down front. That's going to give me, oops. So they wanted to know our time is in hours. That's what they tell us. So it's going to take 229.1 hours for our 1 gram mixture to be at 10% of what it had been, or 0.1. Okay? All right, so that's a nice decay problem. Again, we're going to continue to use these types of equations. Growth, we're going to add, and decay, we subtract. Let's take a look at the next one. Suppose a new business borrows $50,000 from you to start up funds. The business will repay the loan in one payment 5 years from now. The interest is at 12.5%. What is the growth factor of the loan? Write the equation of the model to the growth of the loan. Find the amount that the business will owe when the loan comes due. Wow, 12.5%. Okay, so problem number 2. Again, we're going to use this equation. And And our initial amount is going to be $50,000. That this company's going to borrow. They're not going to pay back until after 5 years. So X is going to be 5 years. And we have an interest. The interest on this is 12.5%. So I'm going to change 12.5% to a true decimal, which is 0.125. Is this growth or decay? Growth. The debt is growing and growing and growing. So I'm going to take this. So in order to get B, B is going to become 1 plus whatever our percent is as a decimal. So our B value is going to be 1.125. And we're going to do this. So I get Y is equal to A, $50,000, times 1.125. And we're going to raise it to 5 years. Any idea how much this will be about, you think? Anyone think it's going to be like 55,000, 60,000, 100,000? Order of operations, say do the exponent first, so 1.125 raised to the 5th power times 50,000. So that's what the debt would be that you would owe your company. So someone lent you $50,000, 12.5% interest on the loan. You're going to start paying it back in 5 years. Hopefully your company's doing a little better and can pay that back. Is that all right? Suppose, number 3, says, suppose someone says they will loan you $100. He will charge you 10% interest per day. How much will you owe him at the end of 30 days? Okay, so again, we have our Y is equal to AB raised to the X. This person's going to give you $100, and your interest is going to be 10%. So we want to know after 30 days, that's your X value. Is this growth or decay? Growth, okay. So my B value is going to be 1 plus the percent as a true decimal, 0.10. So my B value is 1.1. My X value is in days. So you get Y equals 100 times 1.1 raised to the 30th power. So you're going to be a little bit more than $100. Ooh. Your friend is a loan shark. I'd say find a new friend. Okay, number 4 says, suppose the retired professor who lives next door to you offers you to work for the next 30 days. He says he will pay you $500 per day, or if you prefer, he will pay you 0.01 the first day and double your pay each day after that. Which option do you want? This is a classic problem. So he's going to give you either $500 or a penny starting the first day and double each day for 30 days. What's that?
She's expecting problems to me.
So the second day you get 2 cents, the next day you get 4 cents, the next day you get 8 cents, 16 cents, so on and so forth. He's going to double it every day. So let's figure this out. Y equals AB raised to the X. If you're going to double something, how do you get there? What would the growth factor have to be? 2. 2?
Well, it'll end up to 2.
Square?
So it'll be 2.0. So Well, let's see the easy way to figure this out. So my b value, we're going to double it. It's going to be 1 plus, I'd say 1 plus 1 to make it 2. I think that'll work. Let's see. If this truly does work, 0.01 times 2 raised to the x power. So the first day is actually day 0, right? If I go 0 here, 2 to the 0 is 1. 1 times 0.01, does that give you your first penny? Okay, then let's go to the next day. So I'm going to put a 1 in here. 2 to the first is 2. 2 times 0.01, there's your 2 cents. If I put a 3 here, 2 to the third power is 2 times 2 times 2, which is 8. Is 8 times 0.01, 8 cents. Yeah? If I put a 4 in here, 2 times 2 times 2 times 2, that's 16. 16 times that. So I feel confident about our thing. If you're going to double the money, you're going to say you're earning 100% more the next day. 100% as a true decimal is 1. So do you take the $500 for 30 days worth of work, or do you take the penny doubling every day? Let's modify it a little bit. Let's say the guy's going to offer you $50,000. You take the $50,000 or the penny doubling each day? About $500,000.
Every day? $500,000 every day.
No, $500,000 for 30 days worth of work, or penny doubling every day for 30 days?
Penny.
Penny? All right, let's take a look. So I'm going to go 2 raised to the 30th power times our 0.01. I'll do the penny. So, great problem. That's one of those you got to think about, because a lot of kids will think, oh my gosh, penny doubling each day. Start with a penny, then the next day I make 2 pennies, and the next day I make 4 pennies. After that I make 8 pennies, and 16 cents, and 32 cents, and 64 cents, and $1.28, and $2.56, and $5.12, and $10.28 or 24 cents. So it doesn't seem like it's going all that well, and then all of a sudden you're like, wait a minute. If this is that 25th, 26th, 27th day, you're getting some righteous bucks. Huh? $10 million to pay out? I don't know how much professors make, but I don't think they have $10 million to give out real quick. All right, write an exponential function to model the following situations. Find the value after 8 years. So 5, 6, 7, if something depreciates in value, growth or decay. Okay? $45,000 investment increases at a rate of 9.8% per year, growth or decay. So remember, decay, you're going 1 minus whatever your rate of decay would be as a decimal. Growth would be 1 plus that. And then the last one looks like you're going to, God bless you, plug this in your regression model in your calculator. So go with that. All right. If you would, make sure your name's on that, and you're all done. Pass it all in. Need more time? Finish it. Get it to me next time. Ready? 3, 2, 1. Wait for the camera to go by. All right. So, you will see some problems like this tonight. Now, a logarithm was developed a long time ago to deal with big numbers. Okay, the logarithm basically focuses on the exponent of numbers. Okay? So, if I wanted to convert log base 2 of 32 to figure out what the answer would be without using a calculator, I have to make 32 be in base 2 form, meaning 2 to some exponent equals 32. Well, I know that 2 to the 0 power is what? 1. And 2 to the first is? 2 to the second? 2 to the third? 2 to the fifth? 2 times 2 times 2 times 2 times 2 is 2, 4, 8, 16. And then 2 to the 6th, 2, 4, 8, 16. Oh, 2 to the 5th, right. All right, 2 to the 5th is equal to 32. So log base 2 of 2 raised to the 5th power, you have to understand that this exponent can come down front. So I get 5 log base 2 of 2. Log base 2 of 2 is the same thing as 1. So this becomes 5 times 1, which is 5. Okay? Log base 3 of 27. I need to put 27 in base 3. So 3 to the first is 3, 3 to the second is 9, 3 to the third is?
27.
So what's the answer to log base 3 of 27? 3. The reason it's 3 is that's the same thing as 3 to the third power. Okay, so if you get log base 3 of 3 to the third, that becomes 1. The exponent comes down front, so the answer is just 3. Log base 4 of 64. 4 cubed. It's 4 to the third power, 64, so what's the answer? 3. Log base 7 of 1.
7 to the 0, 0.
Good. So 7 to the 0 power is the same thing as 1. So I could rewrite this as log base 7 of 7 to the 0, which is just going to be 0. So log base whatever of 1 is going to be 0. And then last one. How do I convert 5th root squared? 5th root squared. How would I rewrite 5th root squared as an exponent rate or an exponent fraction? 2/5. Good. So this becomes log base 3 of 3 to the 2/5 power. So what's this answer? 2/5. So log base A of A becomes 1, and the exponent comes down. Then you have to do a different way on the calculator. All right, so that's the first things you're going to see. Is there any questions about that? So if you have log base something, you want to get your whole number to be in that base form. Okay, so you're going to deal with an exponent. Next one. We would like you to convert it to a log equation. Now, the only way I know how to teach this is something called the shell. The shell or the snail. Same thing. Ready? See if you can see the snail. Ready? Start here. Go there. Kind of look like a shell? Snail? Maybe? Use your imagination. So if I want to convert this to a log equation, this becomes log base 5 of 125 is equal to 3. So we're going to do this as a snail. Ready? How would I write that? There you go. Log base 9 of 729 is equal to 3. How do we do it? So log base E of x equals, does anyone know what this converts to? Natural log, good. ln x equals 5. I would actually accept either answer, but that's the definition of natural log. Last one, ready? Convert with calculator. I think we can do that. Just plug it in, yep. So the first one, you go log 15. Roughly. Natural log of 3. E to the 8th power. Easy as that. Okay, your assignment, this is logs, I will tell you guys and girls, easiest thing to goof you up, easiest thing to work with as well. Don't let it get ahead of you. So, that's what I got for you. Cool? Oh no. 35 through 53 odd. My dyslexia kicked in. 35 through 53 odd.